Hello, I'm Joanne Gallagher, your Think.Future podcast host. Philiip Lund-Nielsen joins us from COBOD International, the world's #1 supplier of 3D printers. Join us in a minute to find out what the opportunities are for using this technology in the built environment. This podcast is brought to you by Arcons, a global leader pioneering solutions and services to the construction and manufacturing industries to support digital transformation for the built environment and smart manufacturing. Visit arcons.world to learn more about how Arcons are helping organizations design, build, and solve through digitalization. From Arcons to you, welcome to our Think Future podcast series. Each week, we'll share conversations with industry leaders from around the world to find out how they're thinking future. Subscribe to Arcons Think Future to access more episodes, interviews, and profiles. Philiip Lund-Nielsen is the co-founder of COBOD International, the world's #1 supplier of 3D printers for the construction industry. COBOD is working together with investors such as General Electric in the US, Holcim Switzerland, Cemex Mexico, and Perry Group in Germany. After acquiring building experience as a management consultant with McKinsey & Company, Philiip rejoined COBOD in 2021 to assume his current role as Head of Americas, managing COBOD's activity in North and Latin America. He joins us today from the company's facilities in Miami, Florida. Hello, Philiip. Welcome to the program.
Hey, Joanne. Thanks for having me.
Great to have you on the show. Philiip, tell us about COBOD, what your role is and how you got into this position.
Of course. So COBOD is a manufacturer of 3D printers for the construction industry. So imagine a large-scale machine that deposits concrete layers upon layers to create a physical structure from a digital file. So what COBOD does is we develop these, we manufacture them, and then we sell them across the globe. And my role is that I lead our activities in North and Latin America from our base here in Miami, Florida.
And where are you from originally?
I am from Copenhagen, Denmark, across the globe.
So you were talking earlier about this was a family affair. Can you explain how you got into this business?
Sure thing. So around 10 years ago, I dropped out of college, and by lucky coincidence, me, my uncle, and some engineers, we came together and we started a small store in Denmark selling plastic 3D printers. So imagine a small scale 3D printer that can print like an iPhone cover and nuts and bolts, smaller stuff like that. And we resold this from this store in Copenhagen. And then what happened was we said, hey, this technology it's great. It has a huge potential. Why don't we try to apply it to the world's largest industry, which is the construction industry? So what we did was we took the concept of the smaller scale 3D printers and we beefed it up. So we created Europe's first 3D printed house in 2017. And from there, it's just been a fantastic journey that has taken us across the globe.
How exciting. We'll get into more of that. But how does 3D printing play a part then in sustainable development of the built environment?
Good question. It's one of those benefits that 3D printing contributes to in the built environment that and something we'll see more of in the future. In essence, when you 3D print, there's various ways. Number one is that you reduce the amount of waste on site. On a typical construction site, the waste factor can be up to 30% because a lot of the materials, the construction materials, are standard sizes that are then cut to fit the particular project. With 3D printing, you reduce the waste factor considerably because you only print what's needed. So that's one way. Number two is that you can print in ways that reduce the amount of rebar or reinforcement, which is steel, that's being used. Steel has a much higher CO2 factor compared to concrete. Now, concrete is not perfect, but compared to steel, it's much better. So if we can reduce some of that steel, it's a win. And there are other factors I could go into, but those are two very, very important ones.
Great. And at what scale do you think in the built environment is it happening at the most effective?
Well, we're addressing with this technology that we sell, or I should say, our customers are addressing many, many different use cases. So if we talk about those first, they're printing homes, they're printing water tanks, they're printing offices, data centers, wind turbine towers. There's a lot of different applications for this technology that each contribute in their own way to improve sustainability. Secondly, when we talk about scale, our machines, the most common printer that we sell, it's called the Bot 2, our second generation printer. That can print up to 30 feet in height or around 10 meters in height. We have also released a machine, and we have sold those. That's called the Bot XL. XL stands for extra large, which it is because that one can print up to 70 to 80 feet in height, which is 20 plus meters, which is equivalent to, depending on where you are in the world, a 5 to maybe 6 story building.
And are these machines for sale or for rent? How does that work?
They are both for sale and for rent. Initially, we have predominantly sold the machines. However, I do think that we will see this industry, not just COBOD, but also our peers. I think we will see leasing becoming more and more available. And that's because if you look at the construction industry in general, it's far more common to lease construction equipment. You don't go and necessarily buy a crane unless you're a huge, huge company, right? You would lease it for that particular project. And that's the direction that we sort of see the industry moving in as well.
We're touching into the business case benefits. You were mentioning some of the environmental benefits. Are there other benefits that you can see?
Oh, yes, there's many. The sustainability factor is 1 out of 4. Number one, I would say, out of the 4 is that you automate the construction site. So on a typical construction site, you will see lots and lots of manual labor. Still, this like today, if you look at a construction site year 2024 and compare that to a construction site 50 years ago, you will barely see a difference. And that's why most studies show that productivity in the construction sector has flatlined or even decreased, meaning the output per worker has gone down or stayed the same. Whereas if you look at other industries like agriculture, look at agriculture, the agriculture industry from the 1950s to 2010, the labor output productivity increased by a factor of 16. You get 16 as much grain or whatever you're producing in the industry per worker compared to 5 decades ago. But that's not been the case in construction, and that's one of the benefits of 3D printing, that you reduce the amount of labor on site, you increase precision, you make the site more safe, and you let the machine do all the hard work.
Is that then what I'm hearing? If there's less labor on site, does that mean there's less workers? It's taking over all of that.
Globally, there is a shortage of skilled labor. In the US alone, there is a need for more than 500,000, 500,000 skilled workers for the construction industry. There is a lot of people leaving the construction industry. There's, however, not a lot of young people that go into the construction industry. And one of the reasons why is that it is hard work to, say, lift concrete blocks while it's 100 degrees Fahrenheit outside. So instead, that's why we said, why don't we let the machines then address that gap? You're not replacing, you're actually just addressing a major gap right now. And the other factor is it allows for upskilling the workforce. So now the operators all the workforce of the future that now has to work with this machine, they can get training, they can get upskilled, hopefully also increasing salaries. So we see this as a plus for anybody in the construction industry.
I'm glad you explained that. That's great. What open source technology can it be used with?
What open source technologies it can be used with?
For example,
Mhm.
you've got partners on your website. I noticed Wholesome. Are you using collaboration with other technologies, etc.?
We have not yet seen a major, you could say, uptake in other types of tools being added to the equipment yet. However, I think that's the direction that we will go in, and that's at least what we're trying to push for ourselves. Is now that we have this 3D printer, could we add additional tools developed by us or by third parties to turn these machines from single purpose construction robots to multifunctional construction robots? So instead of just 3D printing, what if the machines could also plaster the walls, or you could spray paint the walls now that they're printed? It might be able to place conduit. There's a lot of different things that we can do with these machines now that they are on site, in addition to the 3D printing.
So, as far as your collaboration with Wholesome, are they providing the materials for that's been extruded through the 3D printer, or what's the collaboration there?
Sure, happy to talk about materials because that's a very important thing, especially when we talk about sustainability. We decided from the beginning that we wanted to be fully open source with regards to materials, meaning our machines can run most types of concrete or mortars out in the industry. We looked at the paper printing industry, or if the 2D printing industry, if you will, and we saw that, hey, in that industry you often buy a printer, say a printer for the home or the office, but then in many cases the supplier tries to lock you down to their specific ink and toner. And we said, no, that's not going to work for us. We don't want to earn a quick buck on and locking our customers down on a specific material that we sell them. So instead, with our machines, we are big proponents of that customers can mix concrete using locally sourced concrete constituents. So you mix cement, your sand, your aggregates, and water admixtures on site, which means you can do any kind of mix that you want. So some of our customers, they want to experiment with adding hemp fibers or other cementitious alternatives, or there are some that want to experiment with graphene. You add graphene to make the concrete stronger. You can reduce the cement content. There's various ways, or low CO2 cements. We've seen customers do that too. So there's a lot of ways that our customers experiment with it, and they might get their materials from Holcim, which is one of our investors, or they can get them from Cemex, which is the world's also one of the world's largest cement and concrete companies, which is also one of our investors.
There's an eco village in Sydney and New South Wales that is experimenting with 3D printing as well, because they do all kinds of experimentation on low emissions building technologies. And I think they wanted to build a community center, and they were looking at 3D printers, and that's how I came across COBOD because we were researching. So that was interesting. Yeah, you mentioned earlier that 3D printing is just one of many solutions for the built environment. Can you expand on that idea?
Yes, I can. So the construction industry globally is huge. It's $13+ trillion. So it impacts everybody's lives, right? And it also has tremendous issues. The lack of productivity, lack of skilled labor, unsustainable practices, built environment. Construction makes up around 40% of global CO2 emissions. Lack of design freedom. there's a lot of issues to be addressed. And I love our technology. I think it's great, and I think it addresses these issues effectively. However, I'm also realistic that when you have big problems, it often takes more than just one solution. So 3D printing might be one of those solutions out there to address, to make it cheaper, to make it faster, to make it greener, whatever. But other technologies will also be needed, and it's not like we're gonna discard everything else just to go with 3D printing. There will be a lot of important players out there. For instance, I think while concrete is not a perfect material, I still think there's a lot that can be done with it to make it greener, because I don't see it being discarded in the near future. So something like that needs to be further developed. And now that of course works with the 3D printer. So I think that's a great example of how a new technology can come together with an existing one to improve the built environment.
Excellent point. So the 3D printing is very exciting because there's so much innovation that can be expanded upon or developed. What do you think of the limitations of 3D printing?
There are certain limitations that we are trying to address. Number one right now is the regulation is around, I would say, 2 or 3 years behind. As it is often with new technology, regulation lags. And in this case, it lags 2 or 3 years, meaning some of our customers, in some situations, it can take a bit longer to get it code approved because it's a new way of building. So while I do think codes will catch up with this technology, and we're working with many coding bodies to make that happen, that can sometimes be a hindrance. They always get it solved, but it might take a bit longer or a bit more convincing. Secondly, the workforce of tomorrow, we need to upskill and train the workforce of the future to operate this equipment. Architects will need to rethink architecture because now you have full design freedom, which is super exciting. Construction workers, now you need to have somebody that operates the 3D printer. The material scientists will have to figure out how to make the concrete 3D printable on site. It's very exciting that they get these new roles, but it will also take a while before you have a full-fledged construction workforce where everybody can manage that.
What about the supply chain? Do you think it will interrupt or disrupt the supply chain in any way?
I think it will have.
In the normal sense of construction,
I think it could. I think in general, because you are addressing 20 or 30% of the activities on site. If we're talking residential buildings, you might address 20 to 30% of activities or cost by 3D printing the walls, maybe the foundation, maybe the roof. That will impact how we do concrete, how the concrete is delivered. It will also impact other contractors. Say, we heard, for instance, from one of our customers in Germany that the electricians, they said they actually loved working with this new technology because it was much easier for them to do their job, to place their wires, their conduit in between the walls. So there's many facets to this technology besides the printing, and that will impact other parts of the sector.
That's awesome.
Yes.
It is. We'll be back to the conversation in just a minute. In the meantime, here's a little bit more about Arcons. Arcons has a mission to advance the efficiency, quality and profitability of project outcomes for its customers. Providing best-in-class technology augmented by its in-house developed IP and a full suite of professional services, Arcons is trusted by over 40,000 customers globally. If you are looking for a digitalization and sustainability-focused partner to help you achieve your goals, join the thousands of construction and manufacturing customers globally who choose Arcons as their digitalization partner. With more than 50 locations around the world, Arcons can connect you to the right technologies and expertise, so you can improve your competitive position and increase profitability. Arcons has an industry expert to help you navigate the best pathway forward wherever you are on your digitalization and sustainability journey. Visit archons.world to find out more. And now back to our conversation. I just want to go a bit deeper into the technology development from a perspective of circularity. What do you think the opportunities are there to design out waste and improve resource efficiency in the future?
For circularity, some of our customers, they have experimented with their concrete mix, taking, say, rubble that could be from a demolished, a concrete building, or roof tiles. We've seen that too. And they take those and replace aggregates in their concrete mix. So you can reuse existing construction material that no longer has a purpose in the old building and reuse that in a new one, which I think is quite beautiful, and that can further help reduce the CO2 footprint.
I love that. I don't think I've ever heard of that being done so efficiently, actually. That is really cool.
Yes, our customers are quite cool. It does require a lot of patience doing these experiments, which it is. But in time, they will get it right, and then you apply it at scale, and then it will have a meaningful impact.
So obviously, this is having a big impact on reducing emissions as far as the way we measure carbon emissions. If we're using waste and reusing waste like that, can be done quite quickly to reduce carbon emissions, I'd imagine.
Yeah.
Can you compare it like with another technology? Have you done that sort of study?
With regards to waste, as I mentioned earlier, the waste factor on a regular construction site is up to 30%, sometimes more, sometimes less, but sort of can be quite high. It's a lot of material that you throw out just because it came in a prepackaged configuration. With 3D printing, again, it varies from customer to customer, but the best ones we have of our customers, the most experienced ones, they're down to say 5 or 10% when they're printing of the concrete, which is quite a meaningful improvement from most construction sites. And I think it will only improve as we continue.
Great. I was wondering about how it would work with technology like, BIM technology and digitalization, working together with these machines. Have you done anything like that for design?
Yeah, and I have some architecture and engineering colleagues that might be better suited to answer this question. So I'll do it a bit high level. What's quite fantastic, at least to me, from my perspective, is you can actually look at these 3D printed buildings before you print them. We can show the full simulation of all those layers on a PC or on an iPad, and show how it's going to be printed day by day, layer by layer. We can show where, okay, here's where the electrician comes in, here's where he or she would place the conduit, here is where the painter would come in, or here's where the rebar team will place the reinforcement. So it gives you a very good end-to-end and holistic understanding for all parties involved of how things are going to move forward once we go on site. And I think that's an important factor on a construction site, because one of the reasons why construction is so complex is due to the many different stakeholders involved. So if you can provide a bit more clarity even before you start the construction, the printing, then I think it will benefit everybody.
That's one of the big advantages of digitalization and digital twins, that everyone can be in at the beginning and see how it's going to look and make adjustments early before you even start the project. So you're saving and making it more efficient right away, aren't you?
Yes. Anything that can improve coordination on a construction site is so vital. I think one of the most important technologies introduced to a construction site in the past handful of decades is probably the cell phone, because that allows you on a construction site to easily communicate with anybody within that site or any external party. I cannot imagine how it was being on a construction site before the cell phone was invented.
Me neither. You touched into some of the challenges that you're trying to overcome. What are the obstacles and opportunities that you see that need further development? Can you be more specific or?
Yep, developing and training the workforce of tomorrow is very important. So we have a very good training program for all our customers. We're also working with many academic partners and other partners to build training programs that people can join, even if they're not a customer, they can sign up. So those will start to kick off from next year. On our end as well, we think it's important to develop these new tools to take the machines from single purpose to multifunctional construction robots. So those are also in development. I gave some examples before. A third thing is the size itself. I think if we scale the machines up, as we've proven with one of our systems, it allows for doing more applications and existing applications at a bigger scale, which will only increase adoption. So those are some of the ways that we're addressing and I think that like increasing adoption is what's going to transform this industry. When the cell phones, if we circle back to those, when they were invented, when they were introduced, they were very expensive. They had very few use cases and not a lot of people used them. What we were hoping will also, but whereas you compare that today with cell phones of today, they're cheap, fairly cheap. They have millions of use cases, and almost everybody, at least everybody that I know, they own a cell phone. We hope the same thing will happen with these 3D printers.
I presume for a project you can use more than one printer, can you, in a building site?
Yeah, that's correct.
Yeah, okay. So you mentioned earlier about COBOD 2 and now COBOD 3. How did they evolve? What's the difference between these two?
Sure. I can go back to how we got the name in the first place. When we did Europe's first 3D printed building in 2017, we called it the building on demand because it was automated. BOD, building on demand. When we later commercialized and started selling these printers, we became a company of buildings on demand, COBOD, so COBOD. And for our printers, for our equipment, we just call it BOD, building on demand. So we had the first that we sold, we called it the BOD 2. It was the second generation. And now we recently launched BOD 3, the third generation system.
So was there much of a difference in BOD 2 and 3?
The most important factor is that BOD 3 comes on rails, meaning, and this is probably better with if we could show a photo or something, but I'll try to explain it. If the listeners here can think of how a regular 3D printer in plastic looks, it has sort of 4 legs, and then it creates sort of a small cube in which a small print head deposits plastic. It looks a bit, if we're in another industry, it looks a bit like a gantry crane. And that's how our second generation system looks. However, our third generation system, it only has 2 towers, and it comes on rails that are placed on the ground. Imagine rails from like a train tracks placed on the ground. That allows you to push the printer along those rails and basically continuing home after home or another structure by taking tracks from the back and moving them to the front. So you improve productivity because the setup time is decreased.
And it's much more mobile. You can move it around the structure you're building as well, which is interesting.
It's a bit more mobile as well. Oh. There are fewer modules to carry around. Yes.
Excellent. I saw that you were doing a project on social housing. How is that going? That could be a very good case study. How many houses have been built? Where are they? Is it in America or somewhere else?
Sure. So globally, I think there's been printed maybe 300 to 400 buildings, which is nothing if you compare it to the full construction industry. But we're also a very young industry, and it takes time, but we'll get there. And COBOD is the biggest player out there of the suppliers. So we did a tally in 2022 of all 3D printed buildings, of which our customers, they did the majority of them. We're doing a new tally that runs until 23, and we're hoping to release that in the near future. So I can be more precise with regards to how many have been done. Some of those buildings that's social housing. That's been done in Europe. It's been done here in the US, but done in Africa. And the reason is, of course, if they believe they can do it cheaper or faster than conventional, then it makes a lot of sense to apply this tech.
There's a big need for social housing everywhere, I think, even in Australia at the moment.
Yeah.
So I'm sure that technology will be of interest.
It's a common global theme. In the US, where I live, there is a lack of 4 million affordable homes.
Exactly. Yeah. So that's a huge social, benefit from my perspective, that 3D printing can provide social housing that's cheap and affordable and quick. So especially in when there's been a disaster, you can rebuild quickly.
Disaster relief is another thing that we've seen some customers focus on, because it's often hard to get the required shelters up and running in such a short while.
Exactly.
And the good thing is also that concrete is a very strong and resilient material. So if there is a tornado or hurricane or something else, then the likelihood of that building collapsing compared to a wooden structure is typically reduced.
I'm just thinking about other uses like, water infrastructure, dams, and so on that are failing. There are a lot of old infrastructure now in the world around water, and we need to replace it. Do you think there would be an application there for these printers?
There could be. It will probably be some years before you could start and use it for actual projects. But in testing, right now we're already seeing water applications. So we have a customer in the Middle East which has been printing water tanks. So I think they were 8 or 9 meters tall, something like that, but water tanks that were printed out of concrete.
Excellent.
And the smart thing about this was that usually if you do formworks with concrete, the walls have the same width from the bottom to the top, because that's how the form looks. But that's actually not really a good thing, because the water pressure is much, much higher at the bottom than it is at the top. The hydrostatic pressure at the bottom is much higher. And so ideally, you would want the walls to get thinner and thinner as you reach the top of those water tanks. And that's something you can do with 3D printing. And that's something that this customer actually did. So he has 3D printed now 3 tanks that has reduced the concrete usage by a quarter compared to conventional tanks. Quite amazing.
That's a great use for it. Excellent. So as we close out today's conversation, Philiip, when you think future about what you're doing and the potential of 3D printing, what is it that excites you the most?
It excites me tremendously to address issues that affect everybody. We every day, we go to work, we go work in an office, we live in a home, we walk the streets, we drive our cars, we cross bridges, energy infrastructure that powers everything. All of that is enabled by construction, which therefore is the world's largest sector. But all these issues that the construction industry has are not just pertaining to the construction industry, those that are working in the industry. It affects as an example, housing prices, that affects everybody when rents go up, or you can't get work. The roads, the potholes, or the bridges, as you said before, or the dams are starting to collapse. It affects everybody. So it excites me tremendously that we could use new technology to address these issues effectively for everybody's sake.
It's very true and very exciting. Philiip, it's so wonderful to hear what you're doing, to know that you're an innovator and a businessman and out there making the world a better place. So thank you so much for coming on the program and telling us about everything you're at. And we want to hear more. So if you're ever in Australia, please look us up.
Thanks for having me, Joanne. And if you're ever in Miami, please come say hi.
This podcast was brought to you by Arcons. Arcons is leading the digital transformation of the construction and manufacturing industries, providing best-in-class technology solutions from world-leading partners and their own in-house development software from the Arcons B-Smart portfolio for building, infrastructure and manufacturing, and a full suite of professional services. Arcons is a company that cares about creating and building a better world. Together we are working with industry and environmental experts, providing forums and platforms through our Arcons Think community to create conversations that matter to our future generations. We invite you to join in the conversation and participate in our Think community. Like and subscribe to our Think.Future newsletter to stay up to date with the latest innovations and conversations as we advance the digital journey for construction and manufacturing around the world. You can download our podcasts at arcons.world or from your favorite podcast platform. From Arcons Think Future, thanks for listening.